Welcome to the latest BAA Wednesday webinar. As usual, we're running this on Zoom, along with a live stream to YouTube. And the recording will be available to watch on our YouTube channel afterwards. You can ask questions on Zoom by typing in the Q&A, or on YouTube the comments, and we'll answer them at the end of the presentation. It's my pleasure to hand over to Dr. John Mason, the Director of the BAA Meteor section.
Thank you, Andrew. Well, it's been a remarkable year for meteor astronomy in this country. On the 28th of February at 9:54 in the evening, we had an incredible event, a brilliant fireball that was obviously seen by very large numbers of individuals. But what is even more remarkable, that the event was recorded by no fewer than 15 fireball or meteor cameras, many operated by BA members, as part of 6 different networks, ranging from all sky to narrow field systems. And what is also remarkable is that these observations have been analysed rapidly and enabled a meteorite or fragments of a meteorite, carbonaceous chondrite, to be recovered from Winchcombe. A historic event for this country. But that wasn't the only interesting event to occur in the early part of the year, because less than 3 weeks after the Winchcombe meteorite fall, on a Saturday afternoon, on the 20th of March, there was another major event. But this couldn't have been more different than the event on the 28th of February, because the event occurred during daylight at 2:53 UT in the afternoon. And that's the event I want to talk about this evening. And the process of obtaining the observations and trying to work out exactly how this event unfolded has been quite a detective story. As with all these sort of investigations, a very large number of people have contributed. And I would like to thank all these people, plus many other individuals who are not listed here, who contributed to the overall event. There were many members of the public who didn't see the fireball, heard the sonic boom, found interesting rocks in their garden, found interesting things on the beach, found interesting holes as they were out walking in the many weeks and months since this event. And to all of them, I offer my grateful thanks. But there has been an enormous team of people who've helped to pull all of this very diverse range of information together. It was a quiet Saturday afternoon, 20th of March, 2021. When the silence was going to be shattered by a double sonic boom. And this sonic boom was heard over a very wide area, ranging from in the Torquay, Newton Abbot area, up towards Taunton in Somerset, and right across towards the Isle of Purbeck and Bournemouth, and almost up towards Warminster. The number of people who heard the sonic boom runs into many thousands. And initially, people were thinking maybe the RAF Typhoon jets had been scrambled, as has happened on a number of occasions in recent times. But the RAF denied all involvement in the event. And the International Meteor Organization, at the same time, started to collect large numbers of visual reports of a brilliant fireball to the north of France. Most of the reports came from Brittany and Normandy, although some were from further south. And they were all of an event that was over the English Channel, heading roughly from west-southwest towards east-northeast. And this was a plot that appeared on the IMO Fireball website. So on the French side of the channel, we have large numbers of visual eyewitness reports. And on the British side of the channel, very few eyewitness reports, although an exception was here in Pembrokeshire, where we had a visual report of an object in this direction. But none of the people here saw anything. And initially, it was a bit of a puzzle. But one man, Will Gator, put 2 and 2 together. Let's now tune to the BBC News feed on that day. Sonic boom in Dorset blamed on fireball meteor. And I'll come to that picture in a moment. But Will had started to collect large numbers of Twitter reports of the sonic boom just before 3 p.m. that afternoon. And it was clearly heard by very large numbers of people in the eastern part of Devon and throughout Dorset, extending up towards Somerset. At the same time, a weather satellite image investigated by Simon Proud at Oxford Physics, UMetSat, showed an interesting flash. Now I'm going to play this, and the flash is just above here. I'm going to play it. There we are. You just see the flash, which looks like it's in the Bristol Channel. And this was about the right time, although it was impossible to be precisely sure when the flash had been seen by the satellite, but certainly about the same time there was this bright flash on the satellite image. And so Will makes the comment, what follows is speculation, but read reports of a loud sonic boom heard across the West Country just before 3 p.m. I wonder if the bright transitory feature which appears over the Bristol Channel could be significant. Indeed, it is significant, but we'll come to that somewhat later. So let me just go back to the presentation. So it was clear that there was a link between the very large number of visual reports of an object over the channel and the sonic booms being heard in the West Country and the odd visual observations from places further north. The reason why there was this dichotomy between the observations is explained very easily if you look at the satellite picture for that time. So this is the UMetSat image for 1500 that day. And you can see that most of the West Country here is under cloud. There's a tiny little clear patch in Pembrokeshire here, which is where the visual observation was made. But you can see that there's this swathe of cloud right across southern England there. However, when you get to the middle of the channel, it's clear. And in fact, nearly all of northern France here is very clear, but also clear were the Channel Islands. And as reports of the fireball started to come in, and as the news media started to get hold of this event, other sightings from across the channel became known, including a dash cam video of the fireball from a man, Ian Dryhurst, who was driving northwest out of St Helier that afternoon. Now, this is a still frame from the video. And if you look just there, there is the fireball. I'm going to show you some more images in a moment. Now, the actual video itself that Ian obtained was bought by the Independent Television News, and it's on their website, but I can't actually show you the video myself. However, I can link to the ITN News website and show it there. So, meteor sighted over Jersey. Let's play the video. So this is the dash cam video. There's the fireball going down, and here it is enlarged. So the video showed that the fireball lasted 4.7 seconds. This image is taken just after about 0.7 of a second after it was first sighted. You can see along the bottom here, we have the time, the date, and we have some coordinates and the speed of the car. Now, having obtained this video, we then set about trying to analyze it. And this is not a trivial exercise because the car is moving. It starts off at 18 miles an hour. It's accelerating to 23 miles an hour. The direction of the car is also changing. So let's go through and have a look. So this is the first view I'm showing you. And what we've got here is a Google Earth view looking down on the road where Ian Dryhurst was driving his car. Now, what was needed to be done was to match the images from the dash cam with the Google Street View images of driving along this road. And it just so happens that the Google Street View images, although they were acquired a few years ago, do follow very closely the path of Ian Dryhurst's car. Now, he turned out of this road here and turned into this and was driving up this carriageway here. So when the fireball was first seen, the car was there. And when the fireball was last seen, the car was there. So the first task is to match all of the frames from the dash cam video to equivalent Google Street View views. And so what we did was we divided the video up and we took a still frame every half a second through the video. We took a couple more at the beginning because the fireball was very faint to start with and then noticeably brightened between 0.3 and 0.5 seconds into the video. So we have a total of 12 images from the video, which we have matched to Google Street View views. Now that enables us, so here's another shot, there's the fireball in the middle. So we basically take the Google Street View image that matches this with the position of the car, and then we use the position of the fireball in the frame. We get the coordinates of the fireball in the frame. It's a 1920 by 1080 pixel camera. And we then match this to the Google Street View and drop a vertical down and look at the bearing. We also double check by doing a number of different measures in different ways to see what we get. So that way you can get 12 compass bearings. I'm going to step through the images. You'll see the fireball moving, but of course the car's moving. So the fireball is moving relative to the nearby scenery and also relative to the more distant village buildings and landmarks. So having got the 12 compass bearings for each of the images at known times, the task then was to go back to the bird's eye view, knowing the position of the car when each still image was taken, to then look at the compass bearing and work out the altitude of the fireball. So we're able to get compass bearings from the bird's eye view, knowing where the car is, and we're able to get the altitudes from the street view. And you end up with 12 pairs of readings, 12 compass bearings, 12 elevations. One of the tricky things is working out where the horizon is. And so a number of different methods were tried to determine the angular elevation of the fireball above the horizon from the street view images, matching them to the pictures. And at the end of it, averages were taken and the figures are shown here. So here are the 12 readings of compass bearing and altitude in degrees that were derived from the measurements. And then a cubic regression was fitted to those points. And the residuals are shown here. You can see that the scatter is fairly even about the line, and in nowhere is the scatter more than about 0.15 of a degree plus or minus. So it's quite a good fit. So that enables us now to know the elevation, angular elevation above the local horizon of the fireball at different compass bearings from where the car was at the time. Now, as a result of an appeal on Channel TV, a lady called Emma O'Prey came forward, and she'd been out that afternoon in Jersey with her daughter Kitty, and they'd stopped by this field looking at the view. You can see the bank of cloud, by the way, from the middle of a channel extending towards the UK, but you can see it's completely clear here. And while they were sitting admiring the scenery, this daylight fireball comes into view. And Kitty, with great presence of mind, grabs her iPhone 8 and snaps a single shot. She does it very quickly. She's still got a bit of her finger over the lens, but she actually did record it, which is pretty remarkable. And there we are in the top left corner again, and then enlarged. So given that she saw it, had to pick up the phone, point it and snap, I think it's a remarkable achievement that in that short period of time, she managed to get a still image. Now, it's quite hard from this image to work out anything particularly meaningful in terms of compass bearing and altitude information. There are no really obvious landmarks here, and the Google Earth view from this spot is slightly different in terms of the trees and the hedgerows, and it's very hard to use that, particularly also as the fireball is well over towards the top left corner of the screen where the distortion in the lens is greatest. So it's an interesting shot, but we weren't able to use it in the analysis. So we're going back to the bird's eye view again, looking down at where the car was when first seen and where it was when last seen. And for each position of the car along this road, bearings have been laid off in the direction of the UK. And here you can see two red lines coming from St Helier. The one here is the compass bearing from when first seen, and the one here is the compass bearing when last seen. And you can see that it does extend across that part of the West Country where the sonic booms were heard. But what you have no idea of is where within these lines the path of the fireball is. Is it going like this? Is it going like that? Is it going like this? How can you possibly find out? Not easy, given that we've only got one video. So the first thing that I did was to take the first line here, which is the compass bearing when first seen, and worked out where the fireball would have been if its altitude at that point had been 90 kilometers, 85 kilometers, 80 kilometers, or 75 kilometers. That range of altitude values is fairly typical for what you'd expect for a fireball when seen under those circumstances. And that's the result. So you can see there that we have the 4 different altitudes, 4 different markers. And so if the fireball was at 90 kilometers altitude, we still don't know where it's going. Or if it's 75, we still don't know where it's going. So we've got to try and pin it down another way. And this is where we had to use a very different technique to establish the trajectory of the fireball. And we did this using the sonic booms. Now, thousands of people heard the sonic booms that afternoon. But in order to be able to work out the distance between an observer and the path of the fireball in the sky where it passed nearest to them, there are a number of things we need. First of all, we need to know the time at which the fireball passed by. And secondly, we need to know that their sound recording has an accurate clock associated with it. Most people who just heard the sonic boom didn't happen to be recording the sound at the time, but there were some exceptions. At the very beginning, I showed you a clip from a doorbell camera, and that doorbell camera had a clock on it, and it also had the sound. Now, in the cases where people had a sound recording and a clock associated, the first thing I did was firstly to try and get hold of the video, and secondly, or the recording, and secondly, to get the people to check the clock on whatever device they were using. Now, the first of these recordings that we had a chance to use was from East Fleet Touring Park. And we're very grateful to Richard Stamper, who is at the park, from not only getting the security camera footage and making it available to us, but also checking that the clock on the camera was accurate. And he did this, and that was one of the recordings we were able to use. At the same time, we became aware of a recording made by a quite unique installation, which is an infrasound array in the grounds of Winfrith Power Station, operated by Optosense. And this is a long array of sound detectors, which can be used for measuring not only the speed of an object through the atmosphere, but also its direction as it passes by. And that would be extremely useful. So we started off with just the recording from East Fleet Touring Park and the recording from the Optosense array. Various appeals went out on BBC Radio Solent and in the Bournemouth Echo newspaper, and various appeals on Facebook and Twitter for anybody who might have a security camera or a doorbell camera that might have got the sonic boom on it. Now, we didn't have a great response. There were a number of disappointing answers to the question. We had a gentleman who was recording bird songs on Portland Bill, who had recorded the sonic boom, but unfortunately had erased the tape as soon as he got home because didn't think it was of any importance. We also have a couple of instances where we have recordings where we do not have an accurate clock on the recording. So although we have a clear recording of the sonic boom, actually being able to place that in UT time that afternoon hasn't so far been possible. And we've also had a couple of instances where people have recorded the sound on their security cameras, but they are not willing to release the footage for security reasons. So at the end of the day, we didn't have as much information as we would have liked, but it turned out that what we had was very, very useful indeed. This is East Fleet Touring Park. Hopefully you'll be able to hear the sonic boom. There we are. And the pheasants. Notice the sonic boom is double again, just like the double sonic boom on the doorbell camera that I showed at the very beginning. So, knowing the time at which the sound was heard, we were then able to lay off the bearing from St Helier to the touring park and work out the time at which the fireball would have passed closest to here. And the difference would have given us the distance from the touring park to the fireball trajectory. But you have to make allowances for a few things. For example, here you can see a sound source moving horizontally there, and the sound waves propagating out from the path, propagating out at the speed of sound. So if you know the average speed of sound in the lower atmosphere, you can use that, knowing the time difference between when the fireball went past and when it was recorded on the CCTV, to work out the distance to the track. This shows you how the average speed of sound varies between 40 kilometers altitude and ground level. And the average is 305 meters per second. And that is the value that I have used in deriving distances. So in the end, I had 4 sound recordings where there was an accurate time associated with that recording. So for each of those recordings, I was able to work out the distance from the observer to the fireball path. Now, obviously, that is, if you like, the hypotenuse of a triangle, the other sides of which are the height of the fireball above the ground and the distance of the observer from the sub point of the ground track. So you have, obviously, you know the hypotenuse, you have a lot of variables. You increase the height, you decrease the ground distance, you decrease the height, you increase the ground distance. So you have a number of variables at play. This is the infrasound recording from OptaSense. And you can see the array, the channels of the array, and you can see that the sound arrives here. And from this array, they were able to tell us not only the elapsed time between when the sound reached OptaSense and when the fireball passed by, but they were able to tell us pretty closely the direction of the fireball at closest approach. And it was a bearing of 326 degrees from OptaSense. So using that information and the 4 recordings, so we had a recording from Langport in Somerset here on a CCTV camera. We had the recording from Easterfleet Touring Park. We have a recording from Dorchester, and we have the OptaSense array recording. And as you take this line of trajectory, you can obviously move it up, you can move it down, and you can rotate it around. But as you do that, you find that if you can fit 1 or 2 points, you can't fit the others. We also have an altitude measurement from Jersey also. So we have basically 5 points along here, and it's a case of adjusting the track so that the points fit. Now, this line, this turquoise blue line, is a bearing of 326 degrees from OptaSense, which is there. The fireball would have passed at right angles to that, this being the point of closest approach. So if you lay off a line at right angles to there and see how the points fit. And you only need to juggle it by a degree or 2 to get it to fit very well. And you can see that the altitude of the fireball is decreasing. 38.5 kilometers, 35.5, 34.7, and 33. The figure from the dash cam gives about 35 kilometers, but that is obviously subject to an error of a kilometer and a half because of the error bar on the measurement of the dash cam footage. But all of these fit in really well. So if we now slide this back, we've zoomed in a bit and we can see now more accurately all of the different points where they fit along the line. So Eastfleet Touring Park, Langport, Dorchester and Optosense. We take the track back and we find that that track hits the 90-kilometre mark on the line. Remember, we laid off this line when first seen, and I put a number of altitudes. I didn't know which one it was going to be, but lining this up, it means it starts at 90 kilometres. If we lay off a point in the middle here and use the elevation as measured on the dash cam footage, we have an elevation there of 62 kilometres. So we're going from 90 to 62 and then to about 39 down to 33. The angle of descent is about 25 degrees. So here we can see a bit of a close-up there looking into Lime Bay there, and we can see a close-up of the track where it starts, 90 kilometres altitude. When first seen on the dash cam, there's a few other dash cam measures here to when last seen on the dash cam. That doesn't mean that the visible flight had ended at that point. It may have continued on, but not been visible from Jersey because it was extremely low and may have either been too faint to be seen or may have disappeared behind some street furniture on the dash cam image. But nonetheless, the 4 sound recordings and the elapsed times do fit in very well with the direction as indicated from the Optosense array. Now, this cartoon shows what happens when a bright, potentially meteorite dropping fireball comes through the atmosphere. It becomes luminous at a height of 85 to 90 kilometers, and it ceases to be luminous around about 30 kilometers. Now, in our case, we have it starting at 90 kilometers and ceasing to become luminous around the 33, maybe slightly less mark, and then the so-called dark flight starts. The question is, were any meteorites dropped by this event? And it's extremely difficult to establish where the strewn field would be, given that our knowledge of the fireball's trajectory is not constrained as accurately as we like. What now needs to happen is that laying off more of the vectors from St. Helier at different times along the path is to work out the changing atmospheric velocity, and then to fit a dark flight path, if possible, to that. Now, if you extend the path beyond the last measurement point from Optosense in the same direction, this line is 50 kilometers long. The white line is 50 kilometers long. And if there were any fragments dropped, our strewn field would be somewhere along that line. Now, about a week after the fireball had gone over, I visited this area and put a lot of cards in newsagents' windows, church notice boards, various village notice boards all along this line, asking people to keep an eye out if they had seen any unusual rocks in their garden, anything unusual happening the previous week, whether they would let us know. We got a few interesting responses. None of them were of anything meteoritic. However, one thing I noticed, and speaking to farmers in the area, was that the week between the 20th of March and the end of March was a very rapid growing period on the fields in this area. And in fact, plants which had only been an inch or so high on the 20th of March were in some cases nearly a foot high by the end of the month. And so if anything had fallen, and this is a very, very rich agricultural area along here, if any fragments had fallen, they weren't falling onto bare soil. They were falling onto fields where crops were growing, and growing at quite a rate during that last week to 10 days in March. So unfortunately, we cannot be certain whether any fragments fell. We hope that we might be able to determine some more information about this. We do have a couple more sound recordings that I'm hoping that we may be able to get a bit more information on. And of course, we still have to complete the full analysis of the atmospheric path, because pinning down this bit of the track shows that it all ties in quite nicely. Now, the very first part of the track, when first observed from Jersey, starting at 90 kilometers altitude, the average velocity of the fireball in this period was about 33 to 32 kilometers per second. Probably a little bit more than that if we had been able to see it earlier. But that is a very high entry velocity for a potential meteorite dropper. I've consulted a number of different scientific papers about entry velocities of meteorite dropping fireballs, and the highest measured velocity I could find for any meteorite dropping fireball was 28 kilometers per second. However, that was for chondritic material, which is more brittle and friable than iron meteorite material. And when you look at the video from Ian Dryhurst's dash cam, what does strike you is the very uniform brightness of the fireball as it travels across the sky. There are no massive flares or outbursts like there were for the Winchcombe fireball. For the Winchcombe fireball, there were multiple in-flight bursts. Here, there appear to be very few or none. And that may indicate we are dealing with a quite hard lump of material. Maybe we are dealing with a lump of iron material. And if that's the case, then maybe something might have survived to reach the ground. It's extremely hard to say. So at the moment, we are still collecting information from this area. And of course, a lot of crops have been harvested this month. And so a lot of the fields that might have had something drop in have not only been harvested, but all the machinery driving over them, maybe turning the soil over, will perhaps have eradicated anything that may have fallen there. So I think we have to say that this may against it.
John, I think
The
we may
high
be losing your sound.
velocity. Oh,
I think just
can
for
you
a
hear
second
me?
there, unless it was me, it was just about 5 or 10 seconds. It all went a bit hazy.
Is it okay now?
Yep, good now.
Yeah. So we're still collecting information. We want to model the path. Now we've got a lot of altitudes along the trajectory. We can start fitting it to a velocity curve and looking at the deceleration and seeing what might have happened beyond the optosense array measurement. Now, you may recall right at the beginning, I showed in that Twitter feed from Will Gator and Simon Proud a satellite flash over the Bristol Channel. Now, analysis of that flash indicated that the position over the Bristol Channel was not correct because it did not take account of the fact that the satellite was in geostationary orbit and some way to the east, which means that the position of the flash in the atmosphere was not over the Bristol Channel, but more likely over Lyme Bay. And the position varies with the altitude of the fireball track over Lyme Bay. So here you can see some calculations. I'm grateful for Jim Rowe for providing these. And you can see that was the position of the flash over the Bristol Channel. And then at intervals of increasing altitude, the position is pushed south and east. And the very last one of these lines is an altitude of 60 kilometers. And it's very close to the position of the track, which was 62 kilometers about there. So it may be possible to tie in the position of the trajectory with the flash seen on the satellite image. And if we were able to do that, that would be very exciting indeed. So in conclusion, this has been a very interesting exercise because it has brought together a completely different range of disciplines to those which were applicable in the case of the Winchcombe meteorite fall. Analysing daylight fireballs like this one is always going to be difficult, but the sonic booms and the timings of them have really helped to pin down the path of the fireball, and it may well be that others do come to light. I'm sure there must have been other doorbell cameras that were in the area, but despite multiple appeals on radio and in the newspaper, we haven't actually obtained any more. So that's the current update on the daylight fireball of the 20th of March 2021. Not as historic as the Winchcombe fall, but certainly a very interesting object in its own right. Thank you.
Thank you, John. That was absolutely fascinating and a real detective story. For anyone who'd like to ask questions, you can type them into the Q&A on Zoom, and I'll keep an eye out for any comments on YouTube if anyone watching there would like to ask any questions. And also, just while I give it a minute for anyone to type, just to say that our next Wednesday webinar will be on Wednesday, the 13th of October at 7 p.m, when we will be hopefully having live observing with David Arditi, the director of the BA Equipment and Techniques section. Of course, that will be dependent on the weather, so fingers crossed for there. And in between then and now, the radio astronomy section also have a couple of Zoom meetings going on. I can see we have a question from Darryl Dobbs, and he's asking, would the fireball be picked up by air traffic control radar or amateur radio receivers?
Right, thank you, Darryl. Great question. Thanks for tuning in. We have already checked a lot of the amateur radio receivers. Obviously, a lot of people are tuned into the Grav receiver, and the reports that we've had is that there is no radio signature that appears coincident with this event. Now, as for radar, that's very interesting you mentioned that, because I did contact Herne Airport to see whether there was any information available for that, but didn't obtain a reply. I also tried to see whether RAF radar, because military radar is of course covering this area, whether they have any information, but I drew a blank on trying to find out who to contact to get that information. I am quite sure that military radar will have something that picked up this event, because it obviously was a major event. But the problem at the moment, I haven't been able to find out who in the military you contact to try and get this information. But it's a very, very good line of investigation, and I shall certainly pursue it.
Yeah, no, that's great, John. And actually that answers the next question, which is from Rob Davies, who was asking whether civil or military radar may have picked it up.
Obviously, the altitude is very high for civil radar, but for military radar, particularly radar that might be looking at missiles or things like this, it's certainly not beyond the bounds of possibility that military radar has picked something up. I know of previous examples where fireballs have been picked up by military radar, so it's certainly a possibility.
And certainly very lucky with that acoustic array.
Yeah, the OptaSense array has produced a gold mine of information, and they're actually using the event to help calibrate the array. So it's a two-way street, if you like, in providing information. But when they were able to tell us that it passed closest to them at a particular bearing, and then I dropped the line in and just tweaked it a couple of degrees and found that I got the fit with the sonic boom records, I was overjoyed, to say the least.
Mm. Oh, it's very impressive. And also very impressive with the dash cam analysis.
Yeah.
Do you know what they normally use the OptaSense for then?
No. I'm guessing as it's closed away from the public, that it's probably used for various usages that may be military applications, or it may be a technology test bed for a number of different applications. But it's certainly really, really good that the scientists there have shared their data with us, and we are, very grateful to them for that.
Yeah, it's fantastic.
And that I was going to put the list of acknowledgements back on there, because you can see Roger Quickmore of OptaSense and Alistair Godfrey are both mentioned there.
And then there's a sort of related question from William S, who asks,
William Stewart. Yes, hi, hello, William.
Any idea how extensive an infrasound detection network exists in the UK, and should the creation and expansion of one be a worthwhile endeavour for fireball trajectory?
That's very interesting. To my knowledge, William, the OptaSense array is the first. It's, I think, a technology test bed. They're obviously evaluating how it works and what it can be used for. I would suspect that setting it up is a very costly exercise. But it'll be very interesting if there were any more like that. Certainly, that's the only one I'm aware of. But as I say, until the scientists there reached out and made the information available to us, we obviously weren't aware of its existence.
And we have a few comments coming in on YouTube as well. So Honor W says, great talk, John, thank you. There might be a chance of finding something on the ground if you contact local metal detectorists on the track.
That's an interesting point. I haven't done so, mainly because the area is pretty vast. I don't know whether there are metal detectorist clubs that are in different towns, a bit like local astronomical societies. There are local astronomical societies in different towns or areas. Maybe metal detectorists have something similar. I have to say, most of the metal detectorists that I know are loners. They tend to go out either on their own or with a friend, and they don't tend to be part of a bigger club or organization. But it may be that such things exist. It's not an area that I have explored so far. If anyone has any knowledge of the metal detecting fraternity, please let me know.
And on a sort of related topic, we have Axrav on YouTube asking, what will be the search area for the meteorites?
Now that is a difficult one. One of the things in our favour is that the winds were very, very light that afternoon. At ground level, they were only between 3 and 4 meters per second. What they were higher up in the atmosphere, we don't know. And there was a number of Met stations that were not able to provide. I did try and get information about upper atmospheric winds, but certainly I've not been able to get anything worthwhile about that. But certainly at ground level or in the lower atmosphere, winds were very light, as I say, only a few meters per second. Now that means that if there is a strewn field, it's going to be centered perhaps roughly along that white line, maybe slightly, very fractionally to the south of it. But working out the position of that is very complicated it's not something that I've managed to do yet, and I should be reaching out to other people to assist with that.
And we have what may be a useful comment for you from Gary Hunt, which he says, regarding the RAF radar, contact UKSA and see if they will intercede.
Okay.
I must admit, I don't know what the acronym UKSA is, but see if we Google. I'm guessing it's the United Kingdom Space Agency.
Yeah.
Rather than the United
I will talk.
Kingdom
I know the
Club.
UK Space Agency quite well from my dealings with Tim Peake and related matters, and I can certainly ask them, but I don't think this is within their area of expertise. But I'll certainly reach out to them and see if they do have a contact. It's certainly a good suggestion.
And then a few more coming in on Zoom, and Clive Morris. So it's very interesting. We enjoyed it, and he's saying, "My uncle was a physicist at Winfrith Heath nuclear power station, where the Opticent array is now, in the 1960s, and he started off in astronomy by seeing the Bovedi fireball."
Bovedi fireball, 1969.
Yep, that's the one.
The Bovedi fireball, yeah. It crossed the West Country and then headed up across Cardigan Bay and ended up, of course, dropping meteorites in Northern Ireland.
Yep, so great connection there. And then from William S. Again, he says, thanks, John. There are Raspberry Pi based detectors. This is to do with the infrasound detection. However, it is an expensive sort of outlay at around about £1,000.
Yeah. It might be something that one might be get a grant to do, but of course you'd probably need them, quite a few of them across the country. It's very nice when you've got something like OptiSense, when you haven't paid for it. Well, I suppose as taxpayer, maybe we have paid for it. I'm not too sure. But when you haven't paid for something, but you can get the data. So that was the best of both worlds, really.
Yeah, and I guess the tricky bit is knowing whether there are other things you can use it for other than just waiting to see if there is a fireball. Yeah,
absolutely. I mean, one of the things that I hope that this webinar might do, I had a lot of help from astronomical societies in the area, particularly the Wessex Astronomical Society in the good offices of Jeff Kirby. But I just wonder whether in that area, up towards Salisbury, Shaftesbury to Salisbury, and in that area, whether there are any societies there whereby it might be possible to reach out to local village organisations or something like that, where there might be people who've got something. I don't know. It's a long time after the event now, but it's always a possibility. It's a fairly empty part of the countryside. I know when my wife and I were driving round it a week after the fireball, and we stopped at small villages pinning notices onto parish notice boards and village notice boards, we were struck by just how very open that area of countryside is.
Yeah, well, fingers crossed. We also have a thank you from Clive Morris.
Thank you, Clive.
And at the moment, no more questions coming in.
Okay.
But yeah, that really was a fascinating detective story, and it sounds like there's a little way to go on it yet.
Yes, I think this is a story that's still got a little way to run, but we are now going to start working on the actual trajectory and maybe looking at where a strewn field could be, if it exists. It may be, you know, you may be only having one object in there. I don't know. It's hard to know. But certainly looking at the light curve, it does appear very smooth, which would indicate possibly a quite hard and durable object.
And are these daylight fireballs really quite rare?
Well, I don't think they are rare. I think they happen quite a lot, but I think it's the fact that are perhaps not often seen. I think the more people are aware of fireballs, I think the more that are being observed. I don't think the number of them is going up. I think a lot more people are aware of them now, so we get a lot more people reporting them. But also, of course, for nighttime fireballs, there's such an incredible coverage of fireball cameras now of all types all over the country, run by a whole range of networks, that a nighttime fireball is going to be fairly rare to get away. But a daytime one, that is always going to be tricky. And pinning it down in the way we've tried to do with this one is always going to be more difficult than with a nighttime one that's obviously imaged by many cameras.
And I don't suppose at this stage you have enough information to know sort of its path on the approach to Earth, where it may have originated.
I don't know whether we'll ever have it accurate enough to ascertain that. We don't really have enough accurate velocity information, but you never know. We might be able to work something out roughly. We'll have to see.
Great. Well, thank you again, John. That really was very fascinating.
Thank you, Andrew, and thank you for your help as well. I hope all the technology worked for people, the various inserts from BBC and ITN.
Yeah, looks as though all those all work perfectly. So thanks very much. I added a lot to the presentation.
Thank you.
And once again, hope to see many of you again on October the 13th at 7 p.m. when we hope to have live observing with David Arditi.
Good luck with that.
Thank you, John.
Good night, everybody.